Good evening to everyone. So let's start today's session. Welcome to this live interactive problem solving session for the Python for Data Science course. So this is our last session. So we have completed like all the 4 weeks contents for the course. So today will be a summary session where we will go through all the concepts that we have seen so far. Okay, so the idea that I had was we will cover the assignment problems from the 4 weeks, right? So it will be like a revision for you. So we will go through some of the problems from the 4 assignments that we have. So if you have any questions other than those that we are covering, you can also feel free to ask those. You can either unmute yourself and ask or put it in the chat. Okay, so that's the plan that we have for today. And I'm Sedu Vinayagan, a PhD scholar in the Civil Engineering Department at IIT Madras. Okay, so let's get started. So, here, just starting with importing all the necessary libraries that I'll be using today. So this is required for the different assignment problems. So I'm just using NumPy, Pandas, and scikit-learn. Scikit-learn for some of the machine learning models that we'll see towards the end from week 4. NumPy and Pandas for data manipulation. Uh, is it only for Vedant or is it for everyone that my voice is breaking? Are others able to hear me properly? Okay, so let's continue. So these are questions from the assignments that you already solved. Okay, so I'll just go over them so that it will be like a revision for you. And if you have specific questions in any of the assignment problems, you can just let me know. Feel free to interrupt and we'll discuss that. Okay, so the first question is what is the output of the following code? So we are creating two variables. A is initialized with the value 3 and B is initialized with the string 12. And if you print A times B, then what will be the output? So the options are 36, 1, 2, 1, 2, 1, 2, 1, 2, 3, or there will be an error. Okay.
Option B, sir.
Yeah. So the right answer would be option B. So why option B? Because so what we are doing here is we are using the multiplication operator, but here we are multiplying a string data, that is the variable b, with the integer data, right? So string is actually a sequence data type, right? And the multiplication operator for the sequence data type is defined as if you multiply it by an integer, so that sequence will be repeated that many number of times. Okay, so here we are multiplying the sequence which is 2 characters 1 and 2, so it is multiplied by 3, so these 2 characters will be repeated 3 times. So that's how the multiplication operator is defined for the sequence data type in Python. Okay, and you have to just remember that string is also a sequence data type, so the output will be 1 2 1 2 1 2, right? So that's how the multiplication operator works. The second one is what is the output of the following code? Array is equal
Minus
to
1.
floor division 7.
Minus 1. Option E.
Yeah, so minus 1. So why is it minus 1? Sorry, minus 2. Why is it minus 2?
How, sir? It is minus 1.28.
Yeah, so minus 1.28, but you have to remember that we are doing floor division, right? So we are not doing the regular normal division. If you do normal division, you would get minus 1.28, but the output of lower division will always be the integer part. Okay, so the integer part is minus 2. The remainder will be some fractional value, right? So if you divide minus 9 by 7, so the quotient will be minus 2. So you can see that. Yes. Right. So if you divide minus 9 by 7, so the quotient is minus 2 and the remainder is 5. Right. So therefore, the floor division would give you only the quotient part. Right. So because it will be always an integer. Right. So we are getting minus 2 instead of minus 1. Okay, question number 3. What is the data type of y in this code snippet? So x is 15, an integer, y is string of float of x. The options are int, float, string, and error.
Sting.
Yeah, so option C, it will be string type, right? So, so the value of y would be 15.0, right? But this is not a floating point number. This is stored as a string variable. So why? So because first what we are doing, we are taking the value of x and then we are passing it into the float function. So the first thing that will happen is this integer x, integer value 15 will be converted into a floating point value. So that floating point value is nothing but 15 with a decimal point and then 0. Right? Then we are taking that float value 15.0 and then passing it into the string function. So what we will get is a string representation of the floating point number. So it will be the value 15.0 but represented as a string data. So therefore the type of y finally will be a string and it will not be float. So the right answer is option C. Okay, so which of the following variable names are invalid in Python? Options are 1 space variable, variable space 1, variable 1, variable with a dollar sign in the middle.
Option A is not valid.
Okay, there can be multiple answers here. A is not valid, okay. Anything else?
D. A and D.
A and D, okay. Is it only A and D?
ABD, sir. ABD.
Yeah. So all the three options A, B, and D are invalid. So
ABD.
yeah, so what is the rule? So why is it invalid? Because in Python, valid variable names can contain only the alphabet, uh, numbers, and underscore, right? So these three only can be present, and also the variable name cannot start with a number. So in option A, so the white space is included, so which is not allowed. Plus, it is also starting with a number, right? So these two make it invalid. In option B, again, it's not starting with a number, but there is a again white space. So again, this is invalid. In option D, the dollar symbol is used, which is also not allowed, right? So only special character that is allowed is underscore.
Underscore.
So A, B, D are invalid. Option C satisfies all the rules, right? So it's containing only alphabet and number, right? There is no other special character used, and it's not starting with number. So C is the only valid variable name. So you can see that if you are trying to use this in the code. So for example, if I start with a number, then Python will give me an error. If I try to create a variable name starting with a number and try to assign a value, it will not allow me to do that. It gives me a syntax error. But if I do something like this is fine, right? So I'm using only alphabets, numbers, and underscore, and it's not starting with a number. So this is a perfectly valid way of writing. This is also fine, right? It doesn't matter whether we use underscore or not, right? It's not mandatory. But if we use any other special characters like dollar sign, so it will still give me an invalid syntax error. So question number 5 is, while naming a variable, use of any special character other than underscore will throw which type of error?
Value error. Syntax error. Syntax.
Yeah, so we just saw that now, right? So when we use the dollar sign, it gives me a syntax error, right? So the right answer is option A. So if we do that again, we'll still see that we get a syntax error. Okay, question 6, let x is equal to Mayur string. Which of the following command converts x to float data type? So options are string of float of x, float comma x dot float, float of x, and cannot convert the given string to the float data.
D.
Yeah, so D is the right answer. So why? So because Mayur is a set of alphabet, right? So characters. So we cannot convert this into a floating point number. So it's just not possible. So therefore, there's no valid way of doing this conversion. So it is going to give us a value error. So this is an invalid value for the float function. But if you have a valid floating point number that is represented as a string, this syntax that we have used, that will work, right? So if you have a valid representation like 12.5 as a string, in that case, you can use the float function to convert the string to the float data type. So this cell will work perfectly, right? So we have successfully converted x from the string type into the float type, as we can see here. So when I use float of x, I'm getting 12.5, right? And if I look at what is the type of that output, it is a floating point number, right? So this is a valid way of converting. Just we need to make sure that the input that we are giving is a valid floating point representation. Okay, so in this case, it was not a number. It was not a string representation of a number, therefore it didn't work. But here this is a perfect number that is represented in the string, therefore we are able to do this conversion, right? So there's nothing wrong with the way we use the float function in terms of the syntax, but the value that we passed was incorrect, so that's why we got the error earlier. So question number 7, predict the output of the following code. So we have three variables, x is 10, y is 5, and z is 3. So if we do x plus y mod z, so what would be the output of it? 12.0, 12, 11.667, and 11. So we have two people answering 12, option B.
B, sir.
Okay.
Sir, one doubt, sir.
Yeah.
Variable name is assigned as A and S then.
Yeah, yeah. So here the variable name
But
is
in print, it's typed as A
okay.
and
So that's just a typo. It should be ANS. Yeah. Thanks for pointing that out. Okay, so let's look at the answer. So the answer is 12. Okay, so how does this work? So here we have two operations that are happening in this expression, right? So there is an addition going on, and there is a modulus operation. So this modulus would give you the remainder of the division operation, right? And if you look at the precedence of operators, then the modulus has a higher precedence than the addition, right? So if you have such a expression, so then what happens is, first this y mod z will get evaluated first, because this operator has higher precedence over the addition operation. So if you divide y by z, that is 5 by 3, then your remainder is 2, right? So this would first simplify to x plus 2, right? So after that, it will become 10 plus 2 because there is only addition left. So your final answer is 12, right? So it is an integer, right? So because y mod z will return an integer value, right? So that is the remainder. And then you're adding two integers. So the addition of two integers will also return an integer, right? So that's why we are getting the final output also as an integer and not as a floating point number. So therefore the right answer is option B. Okay, question number 8 is given two variables j equals 6 and g equals 3.3. If both normal division and the floor division operators were used to divide j by g, what would be the data type of the value obtained from the operations? Right. So question is what will be the output of j normal division g and what will be the output of j floor division g? So the data type, will it be int and int or float and float or float and int and float if the values are this? Okay, both float. Any other answers? Okay. Okay, some people are saying C. So the right answer is actually option B, that both will be floating point numbers. Okay, so here we are creating those two variables, j as 6 and g is 3.3. So if we divide j by g, the answer is 1.818 and so on. And if we do floor division of j and g, then we get the answer as 1.0, right? So this is a floating point number, not an integer. Right? So what happens is, even though the floor division will return you the quotient, the type of that output, whether it is going to be an integer or not, or a floating point number, it will be determined by the operands that you are using. So in this case it is j and g. So here j is an integer value but g is a floating point value, right? So if you use floating point number in your floor division, right? So regardless of whether the output is whole number or not, the type of the output will always be a floating point number. If any one or both of your operands are floating point, then the division operation will always return a floating point number. For example, if we just do see, if we do 2 by 6 by 3 floor division 3, so the output is 2, right? Because 3 times 2 is
3.3 then.
6. But if you use say 3.0, right? So here instead of 3 I'm using 3.0, so in which case it is a floating point value. So in that case the output will be 2.0, right? So the output of your floor division will depend on the type of the operand that you are using. So if both are integers, your output will also be an integer. But if any one or both are floating point numbers, then the output will also be a floating point number. So you have to remember that. And because here G was of floating point type, so the output of the floor division will also be floating point type. So both operations will give you a floating point number as the output. So option B is the right answer.
Sir, but in question number 2, it's minus 1.8 means it's minus 1 then, sir.
No, like here we are saying what is the type of the output variable, right? So here minus 9 by 7. So here both are integers. Minus 9 is also an integer. 7 is also an integer. This will always give you, the quotient part. So if you divide minus 9 by 7, right? So the quotient is minus 2.
Okay, sir.
Yeah, but whether the minus 2 is returned to you as an integer or a floating point number depends on these two values. So here both are integers, so the minus 2 is returned as an integer.
Sir, minus 9 by 7, it is minus 1.28. But in floor division, how it comes minus 2, sir? Minus 1 then.
So this is you are representing it as a fractional number. But if I don't want to represent this as a fractional number, but I want to keep both the quotient and remainder, So then it will be minus 2 and 5, right? So if you do the regular division, so where you keep, so 7 times minus 2, so that would be minus 14, right? So minus 14 plus 5 is minus 9, right? So if you keep the remainder separately, so then the quotient is minus 2. But if you represent it as a fractional number, then it is minus 1.28. Right? So minus 9 is equal to minus 7 times 7 times minus 2 plus 5. Right? So if you write it in this form, so then the quotient is what? So 5 minus 2 and the remainder is 5, right? So this is what the floor division will be doing. So floor division will return you the quotient part, the modulus will return you the remainder part. But if you represent this as a fractional number, so then it would be minus 1.28.
Okay, sir.
Okay, so next question, number 9 is, let A equals 5 and B equals 3. What is the result of the following operation? Print A ampersand B. So options are 3, 7, 5 and 1.
Will it be A, sir?
Okay, some people say A, some are saying D. So the right answer is actually option D, it will be 1. Okay, so how do we get this output? So what is this ampersand operator? The ampersand operator is a bitwise AND operator, right? So which means we have to look at the binary representation of A and the binary representation of B, and then the AND operation is done for the corresponding bits in the binary representation. So if you want to look at the binary representation of a value in Python, you can use the BAN function, that stands for binary. So if you look at the binary representation for A, so A is actually containing the integer value 5. So 5 is represented using the binary 101, and 3 is represented using the binary representation 1, right? So if you make them of equal size, then it will be what? 101 and 011, right? So the leading zeros in the binary representation does not you can add as many zeros as you want, it will not change the value, right? So the leading zeros does not matter, so I'm just padding on the left side with 0, so that we have the same number of digits in our binary representation, right? So what we are essentially doing is the bitwise and between these two binary values, right? So Python will first convert these into the binary values, and then it will do this bitwise AND operation, right? So here what we will do is the corresponding digits in the binary representation, so we'll be applying the AND operation, right? So what does AND operation do? So AND operation is basically, if you have two boolean values, say if one value is true and the other value is also true, then the output will be true, right? So this is the only combination, so that will give you a true value. Any other combination, true and false, false and true, or false and false, this all these three cases will return the output as false, right? So that's what the AND operation will do, right? So it will look at two boolean values, and if both are true, then the output will be true, and if any one of them is false, or both of them are false, then it will return false, right? So that's the output of the AND operation. And in Python, right, 0 will be considered as false and non-zero will be considered as true, right? So therefore 1 is true and then 0 is false. So we look at the first bit, right? So in both numbers, both binary representations, they are set to 1, right? So 1 and 1, right? So it will be 1, right? So because both are true, so the output is true. If you look at the second digit, so in this right hand side it is 1, but in left hand side it is 0, right? So one is false, the other is true, right? So in that case, the output will be false. And in the third digit, so again one is true and another is false, so the output will be false, right? So this bitwise and finally evaluates to 001, right? So this is the final binary representation, and when we are printing this, we will get the integer value corresponding to this binary representation, right? So what is the integer which has this binary representation 001? So that is the value 1, right? So value 0 has binary 0, value 1 has binary 1, right? So value 2 will have the binary representation of 1 0, value 3 will have 1 1, and so on, right? So 001 is same as 1, so that is the integer, that is the binary representation of the integer value 1. So therefore the output is 1. Is it clear? Yeah, you don't have to remember, so you can use the binary function to get the binary output. Which of the following object does not support indexing? So the options are tuple, list, dictionary, and set. Yeah. So option D, set is the right
So
answer. Okay. So what is,
option B.
yeah, what is indexing? So this we studied in the context of collections, right? So sequence data types, so where we have one object which has multiple values in it, right? So we looked at the tuple data type, list, dictionary, and set. So by indexing, what we mean is we are referring to a particular value within this collection, right? So when we want to select a particular value or a set of values, so we'll be going for this indexing. So index is nothing but a position of a particular value within that collection. So here I'm just creating those four data types. So the first object A is a tuple containing 1 2 3 4. B is a list containing the same values 1 2 3 4. C is a dictionary which has strings as the key and integers as values, and D is a set containing four integers, right? So here first what I'm doing is trying to get some values out of the tuple, list, and the dictionary using index. Right? So from A, I'm just selecting the first element represented by index 0. I get 1 as the output. Right? So because it is the first element. From B, which is a list, I'm getting the value at index 2. So index starts at 0. So this is at index 0. This is at index 1. And this is at index 2. Right? So the value 3 is at index number 2. So I'm getting 3 as the output. And C, we can index the dictionary using the keys that we have used in the dictionary. So we have the keys X, Y, and Z. If I index using the key Y, so then I'm getting the corresponding value, which is 2, right? So this is possible. So from tuple, list, and dictionaries. But if I do something like this with the set, which is D, if I try to access some index, so here I'm using 1, then I get a error, right? A type error that set object is not subscriptable, right? So because in sets, the order of the elements is not guaranteed, right? So we cannot say that one will be at index 0, 2 will be at index 1, and so on, right? So set will not guarantee that a particular ordering of the elements. So therefore we cannot use indexing to access the elements in the set, right? So we can only check whether a particular element is contained within the set or not, right? So we can use the in operator to do that. For example, I can do 2 in D, right? So I can do something like this, right? So it contains 2, but it does not contain the value 5, right? So I can do this set operations and membership operations, but I cannot do indexing in sets, right? So only tuple, list, and dictionary supports it. So the right option is option D. Okay, question 11. Given a numpy array ARR, so which is containing this value, what is the output of the following command? So print array 0 1. Yeah, so someone has commented dictionary is also unordered. So in earlier versions of Python, I think up to 3.6, the ordering was not guaranteed in dictionary. Like for example, here I created, the key X, then Y, then Z, right? There was there from the collections module, there is a special version of the dictionary called ordered dict, which will maintain the order. But in latest versions of Python, the normal or the regular dictionary that you create will maintain the objects in the order in which they are created. For example, X will be in the first position, Y will be in the second position, and Z will be in the third position. But regardless of that, in dictionary we do not use any integer positions to retrieve it, even if it is not in the same order. What we are doing in dictionary indexing is referring it by the key, right? So where this Y is stored doesn't matter, but we can always retrieve the key Y from the dictionary, right? So even though if order is guaranteed or not, it doesn't matter for dictionaries. Now for question 11, so any answers for 11? Okay, option C. Anyone else? Okay, B. Let's just create that array and see how it looks. Okay, so visually, if you look at it, it will be more clear. So this is how the array is represented, right? So it looks like a two-dimensional array, but actually it's not two-dimensional. It's actually three-dimensional. If you look at the shape, there are three dimensions, right? So there is a outermost, list. Within that, we have, another list containing lists, right? So there are three dimensions, right? So if you look at it, three sets of, list that we have. So if you look at shape, the first dimension is one, the second dimension has three, and the third dimension has also three, right? So this is uh, a three-dimensional array. So when we are doing array of 0 1, right? So the 0 represents to the first dimension and the 1 represents in the second dimension, right? So we have actually one 3 by 3 array, right? So in ARR there is one 3 by 3 array, right? So this 3 by 3 array is a two-dimensional array. So within that, if we say we want the first element, so it means that, so in a two-dimensional array, so we have the elements represented using the different rows, right? So when we say the first element in this 3 by 3 array, so which means that we will be taking the second row, right? So the first row has index 0, the second row has index 1, and the third row has index 2 within the 3 by 3 array. But first we are saying which 3 by 3 array to use. There is only one 3 by 3 array, right? So we are taking the first 3 by 3 array, that is at index 0, and then within that we are selecting the first row, right? So therefore the output would be 4 5 6, that is the second row. So you'll have to use this indexing from the outermost dimension. So the first index that you use will be for the outermost dimension, then the next index that will be used for the second dimension. Okay, so moving on. So question number 12, what is the output of the following code? So we have a set S containing 1, 2, 4, and 5. And then we are creating an empty list, and we are looping over the length of S, and then adding this list to new list, which increments the value by 1. And if we print it out, what will be the output? Okay, some people say option C, 1, 2, 3, 4. Right. So the right answer is also 1, 2, 3, 4. Right. So how is this happening? So So some may have a doubt that whether we are iterating over the set, right? So we are not iterating over the set. So what we are doing here is we are finding out what is the length of the set S. So what will the length function do? It will tell us how many elements are there within this collection, right? So or the sequence data. So we have four elements, right? So 1, 2, 4, and 5. So the output of the length function would be 4, right? And then we are creating a range object with the output of the length of s. So what we are doing is we are creating range of 4. So what will range of 4 give us? So it will give us 0, 1, 2, 1, 3, right? So because when we specify only one value for the range function, so then that value is used for the stop parameter, right? So the stop parameter is not included, and the start parameter will be defaulting to 0, right? So we'll be starting from 0 and going up to 4, but not including 4, right? So when we loop over this range object, I will take the values 0, 1, 2, 1, 3 in each iteration, right? And what we are doing in that particular iteration is we are creating a list that contains the value of 1 plus I, right? So in the first iteration, so we are creating a list 1 plus 0, right? So which will nothing be 1. And the second iteration, we are creating 1 plus 1, right? So it will be 2, and so on. And then in the last iteration, we have 3, right? So finally, we'll be having the list with the value 4. And what we are doing is we are adding this list that we are creating to the list object that we had earlier, right? So what will addition of two lists do? So if we have a list 1 and a list containing another value, so it will concatenate those two lists and then give you another list, right? So it will do concatenation of the two lists. That's how the plus operation is defined for the mutable sequences. List is a mutable sequence. uh, uh, so what is happening here? So when we do plus equals, so this in the first iteration, this is nothing but so L, this can be written as L is equal to L plus 1 plus I, right? So whatever is there in L, right? So L initially is an empty set, an empty list plus 1. So the output of this would be just the list 1, right? So this is overwritten on the same variable L. So in the next iteration when we come back, so L will be not an empty list again, but it will be the list containing value 1. So when we come to the next iteration, so when we do L plus 1 plus I, it will not be empty plus 1, it will be the list with value 1 added with the list containing value 2. So that would give you 1 comma 2, right? And then it is again written over L. So when it comes for the third iteration, so your L will be 1 comma 2, and then the value that you are adding would be a list with value 3, and then so that will become 1 2 1 3. So like this it will go up to this particular part, which is 4. So the final output or the final value of L would be 1 2 3 and 4. So that is the final value of L. Any questions here?
No, sir.
Okay. So question number 13, what is the output of the following code? So we are importing numpy as np and creating an array, so to which we are passing the output of np.arange 15, and then we are reshaping it to 3 comma 5.
Option C, sir.
Yeah, option C. So what are we doing here is, so first, what does np.arange 15 gives us? So np.arange similar to works in a similar way as the range function, right? So when you are giving 15, so this 15 is taken as the stop value, which won't be included, and the start value is 0. So you will be getting an array starting from 0 and going all the way up to 14, incrementing by 1 each time. So this is the output of np.arange 15. So you get a one-dimensional array containing 15 values. And so this is already an array. So if you are passing it to np.array, so nothing happens. So it will just be a no operation. So it will still be the same array, right? So nothing happens there. So array is a one-dimensional array containing 15 values, and then we are reshaping it and giving the shape as 3 comma 5. right? So what does 3 comma 5 means? So we'll be having,
Two-dimensional five values.
yeah, so two-dimensional array, it will convert into two-dimensional array. The first dimension has, three values. The second dimension has five values, right? So in two-dimensional array, so the first dimension is the number of rows. Second dimension is the number of columns. So we'll have three rows and five columns. So these 15 values are arranged in that particular shape. So what it will do, it will take the first five values, right? Put it in the first row. The second five values will go into, the second row, and the third last five values will go into the third row, right? So 0 to 4, the first five values are in first row, then the next five values in second row, and the last five values are in the third row, right? So that's the output of reshape of 3 comma 5, so which is given in option C. So next question, which of the following codes gives the output my friend's house is in Chennai, right? So the question mark is not part of the output. So we have four snippets of code, so which will give the desired output. Yeah, so the recording of this session will also be available on YouTube. Okay, some people say option D. So there may be one or more than one answer. Go through each snippet and then see which will give the right
Yeah,
answer. Okay, A or D. All right. So we'll first try to execute each of these and then see what happens. I have just written those four code snippets in four cells. So if we run the first one, so we get the desired output. My friend's house is in Chennai. So what are we doing here? We are creating a variable place which contains the string value Chennai, and then we are printing this particular string, formatted in this particular way. So where we are saying my friend's house is in, so that is hard coded, and then we have a placeholder, and the dot format function, what it will do, it will take the value that you give it, and then it will put it in the placeholder that you have, right? So if you have multiple values, you can give multiple variables to the format function, and it will put it in place in the same order. Okay, so here what happens, the value that is in the place variable will be used to replace this placeholder that we have here. Okay, so what happens is this part will be replaced with Chennai because that is the value that is contained in the place variable. So what will be the string that will be printing is my friend's house is in Chennai, and that's what we get. So this is perfectly fine. The second one, what is happening? So we are creating the same thing, but only difference between 1 and 2 or A and B is we have replaced this double quotes that we have used here with a single quote here, right? So that's the only difference. But what happens because of that change is we get a syntax error. So why is the syntax error happening? Because we are trying to create a string, right, using single quotes, but within that string we are using another single quote, right? So we are trying to contain one single quote within another set of single quotes. So that is not allowed, because what happens is Python will consider this is where your string is ending, right? So my friend is where the string is ending. It's assuming that, and then what happens? This single quote, third single quote, it doesn't have a pair, right? So that's why this unterminated string literal is happening, because it is thinking that from here another string is starting and that is not ending anywhere, right? So therefore you get an error. So you have to remember that even though you can use single quote and double quotes to create a string, so when you want to enclose one type of quote within another, you have to use the other one. For example, if I have if I create A using single quote, double quote, or with single quote, I get the same output, right? So it doesn't matter. But if I want to do something like this, so when I want to have a single quote in my string output, then I have to enclose it with a double quote. Or if I want to have a double quote in my string, then I have to enclose it using a single quote, right? So that's how you have to use the double quotes and single quotes, right? So if you don't use quotes within your string value, it doesn't matter which one you use. But if you're using quotes within your string value, so then the enclosing quote should be of the opposite type, right? So double quotes for enclosing single quotes and single quotes for enclosing double quotes. So in the third one, what's happening? So third one, we are directly saying print my friend's house is in Chennai, and then still the same error comes because again we are doing the same mistake where we are enclosing single quotes within a single quote, right? So that's not allowed. Last one works perfectly fine. Why? Because we are enclosing the single quote using the double quote, so there is no issue there. Even though we are not creating a separate place variable, we are directly passing in the value, so that's also fine because we are not going to reuse that place variable anywhere. So it works just the same way as the first statement works. So instead of creating a separate variable, we are directly passing the value to the format function, so there's no issue there. So the right options are option A and option B, and B and C will fail because of this single quote double quote issue. Question number 15. Let T1 equal to this tuple and T2 equal to this tuple. Which of the following will not give any error after the execution? So we are doing 5 set of execution. So 1 is T1 dot append, and then 2 we are assigning indexing something and then assigning it to X. We're trying to add 2 tuples, creating a tuple from 2 tuples and then converting it to list and then converting that into a tuple. So which will work and which will fail?
A will not give any errors.
A will not give any error. Okay. Any other answer? Someone has said C.
E also not give errors.
Okay, A and E. Okay. Someone has said B, C, D, E. That is everything other than E. Okay, B, E. Okay, so different people have different combinations, but what I can see is B is there in most of your answers, and E is also there in most of the answers. So okay, let's look at what happens when we do each of these. So I'm just creating the exact same tuples that we want. So T1 is containing 3 integers and 1 string, and T2 has 3 integers. So those 2 tuples are created. So let's try to append a value to T1. So we get a attribute error. Why? Because tuple is a uh, immutable sequence data type, right? So immutable means we cannot modify the tuple once it has been created. And so this append method where we have seen before, we have seen it in list, right? So what that append method in list does, so when you take a value and then append it to a list, it will add it to the end of the list, right? So it will increase the length of the list, by adding the element by adding the value of the element that you give to the existing list, right? But we can't do the same thing to a tuple because it is immutable. We cannot expand it, right? Once it has been created. So this append is not available for tuples, right? So we cannot do this. This append method is just not available. So therefore, append will give you an error. Second, what we are doing indexing on the tuples, right? So first, what we are doing, so we are first indexing the T1 tuple. We are trying to take the second value that is at index 1. So what is there at index 1? So the value at index 1 is an integer 2,
2.
right? So this will reduce to T2 of 2, right? So because T1 of 1 will be reduced to the value that is there at that index, which will 2. So which means that we are doing another indexing. So T2 of 2. So what is there in the second place, second index? 0, 1 and 2. So at the second index, we have the value of 7 in T2. So this will reduce to the value 7, and this value 7 is what getting assigned to X. So if we run that, there won't be any issue. The value in x will be 7, right? So all we are doing here is indexing the tuples, right? So there won't be any issues. But you will have an issue if you use a different index here, right? So suppose if you use the index 2, then you get an error. Why? What is happening is if you use t1 of 2, so there is a string in index number 2 in t1, right? So then what will this be? It will not be t2 of 2, it will be t2 of a string, right? So in tuple, we cannot index using strings. We can only index using the integer values. So therefore, that will give an error, right? So depending on what index you use here, so it will create an error. But in our case, what is given in the question, so there won't be any error because the integer values are being used. So option B will not create an error. Option C, what we are doing, we are trying to add two tuples. So when we add two tuples, what happens is a new tuple will be created. So that will be the concatenation of the original tuples. So T1 had 1, 2 tuple and 4. T2 had 5, 6 and 7. So when we add two tuples, so we are not modifying T1 or T2, right? So but we are creating a new tuple. So and that new tuple is assigned to T3, right? So after doing this, if you look at what is the value of T1, it is unmodified, right? So we have not tried to mutate T1 or T2. So they are still whatever they were originally. So that's why we did not get an error. But we have added these two in that when we added, so we have created a new tuple and that new tuple is assigned to T3. So that's why this did not generate any error. And in the option D, so we were trying to create a tuple containing two tuples, right? So this is also perfectly fine. Again, we are not trying to modify T1 or T2. We are generating a new tuple, so which has two elements. The first element is of type tuple, and the second element is another tuple 5, 6, 7, right? So this is also perfectly fine. So no issues. The last one, we are doing exactly the same thing, except instead of having the elements as tuples, we are going to have the elements as list. So we are converting from the tuple data type to the list data type. So when we pass in a sequence to list function, so we will be getting the output as a list, right? So we are converting the values in T1 into a list type, and then T2 also is converted to a list type, and those two lists are used to create a new tuple, and that tuple is added to is assigned to T3. So this will also not create any error. So the only error will be in option A when we try to modify the T1 tuple, right? So B, C, D, and E will not generate any errors. Okay, question number 16. Let D equals this dictionary. Which among the following will not give the error after execution? So we are trying to index D and then append something. We are trying to index and then assign. We are trying to modify some value, and then we are trying to update some value. So we have one answer, same option C. Okay, B, C, D, A, C, D, A, D. So C and D are there in all the answers. Let's again look at these one by one. Okay, so I'm just creating the dictionary here. So in fact, let's create it before doing all these operations. So first we have this dictionary, and then we are trying to access, right? So we are trying to index, using this key 2, and then trying to append something. So what happens here? So when we try to access, the key 2, so do we have the key here? So we have the key, so that is 2. And so when we index it, what we will get? We'll get the corresponding value, and the value that is corresponding to the key 2 is a list, right? So this d of 2 would be actually, it would be replaced with this list, and list has a append function, right? So this will not be a problem, and then we are appending a value 4. So this will just expand this list from 3 elements to 4 elements. So if we print that, so that works, right? So there is no issue by doing d of 2 dot append of 4, everything works fine. So in the next one, what we are trying to do is we are trying to index the dictionary using the value 0. So what happens here? There will be a key error because this dictionary is containing only two key value pairs. The first one has the key 1, the second one has key 2. So there is no mapping here for the key 0, right? So dictionary by default will throw a key error if it cannot find the key that you are using to index it, right? So because these 0 is not available, it will give you a key error. So this option B will create an error. So option C, what we are trying to do here, we are trying to create a new key, right? So we are again 1 and 2 are there, but the string 1 is not present as a key. But what we are doing here is we are not trying to access that one. We are trying to uh, create that new key in the dictionary, right? So when we do the assignment, so the difference between the previous one and this one is, here we did not try to assign something to d0, right? So we just try to get the value corresponding to that, right? So, and because that 0 was not there, it created an error. Here we are not trying to access the value that is present at present for the key 1. We are trying to generate one, right? So because we are doing the assignment and this is on the left side, so we are trying to assign this value 1 to this key 1 in the dictionary. So therefore, even though that is not already present there, so it will work, right? So it will just add a new key called 1, and then it will assign the value that you give. So this will not generate any error. And the third one, what we are doing, we are using the update function. So update function also, is like a short, it's also like another way of doing what we did in the previous one. So here we can, instead of doing it like this, so we can give multiple values, right? So if you did using this assignment operator, you have to do one by one. But if you are using the update function, what it will do is it will take in another dictionary, and then if you have those same keys in this new dictionary, it will update those values. But if it does not exist, it will create that new value. And because this one is not available in the dictionary D, so it will create that key 1, and then it will add it. So suppose in this update dictionary, if I said 2 and then assigned it with the string 2, so what happens is, so it created a new key 1 and then gave it the value 2, right? So because that was not there in D, but the next value that I have here, right? So this key 2 is already there. So in that case, it will replace the value that is already there with the new value that you are giving, right? So that's why D, after doing this update, contains, the list is replaced with the string 2, right? So that's what the update function will do. If it exists, the key already exists, it will update it. If the key does not exist, it will create one, right? So the only piece of code that will throw an error is option B, because the key was not existing. And if in your if when you are coding, if you do not want this error, if the key is not existing, but if you do not want the error and some default value if you want to get, so you can use the get function for dictionaries. So you can for the get function, you will give the key that you want, and if it suppose that key does not exist, you can give some default value that you want to be returned, right? So if it does not exist, I want -1 to be returned. So in this case, I will not get an error, right? So when I try to access 0, right? So here using the get function, I'm not getting an error because it is not existing. I'm getting the default value. But if the key already exists, so instead of the default value, you will get the value that is mapped to it, right? So if I access 1, I'm getting Python or Python, right? So because it is existing, and if I try to access something that is not existing, I'll get the default value. So you can use the get function if you do not want to face this error. Okay, question number 17. So we are having a dictionary student which contains the key name, age, and courses. So which among the following will return this particular dictionary, right? So we have the same name, age should be updated, and the courses will remain the same, but a new key, phone, should be added. Okay, so which of these code snippets will give us this desired output? Okay, option B. Okay, most of you say option B. Yeah, C. Yeah. Someone has said none of the above also. Right. So most say B and C. Right. So let's see. So what we are doing, so we already saw how the update function works, right? So if that particular key already exists, it will replace the old value with a new value. And if it's not there, it will create that key, right? So when we are doing student.update, right, and then we are passing in this dictionary, so where age has 26, right, so we, because we are already having the age key in the student dictionary, so what will happen is the old value of 25 will be replaced with the new value of 26 when we do this. So if you look at only that happens, right? So nothing else changes in the student dictionary. So if we run this and check, so this is the output that we get. So we have name, we have age updated to 26 and the courses is there. But if you look at the desired output, so it matches up to this point, but we also wanted to add a new key phone, right, with the phone number. But that is not happening in option A, right? So because the new key is not added. So A is not the right option. So if you look at B, so in B we are doing the same update, but in addition to age, we are also giving the phone key with the value 12345 6 that we wanted. So if we do this, what happens? The existing age key will be updated with the value 26, and the non-existing phone key will be added with the value that we are giving, right? So if you look at the output, so the name is unchanged, courses is unchanged, age is updated, and phone is added, right? So this is what we wanted. So the second option B works exactly the way we wanted it. So B is one of the right options. And if you look at C, so what we are doing in C is we are adding this phone key, right? So because phone is not there, right, and we are doing the assignment to the phone key in the student dictionary. So this will create the key that is not existing, and then we are updating the existing key using the update function. So this will also give us the same output as in the previous option, right? So we are updating the existing key using the update function, and the new key is added using the the indexing operation, right? So this also works exactly the same way. So there is no difference in the output that we get. So both options B and option C give us the desired output that we want, right? So we are just doing it in different ways. So both are fine. There won't be any issues. So B and C are correct. Because B and C are correct, none of the above does not apply. So the right answer is B and C. Okay, question 18. What is the output of the following code? So we are creating a variable name containing the string Mahesh, and then L is an empty list, and then we are looping over name, and then appending I dot capitalize to it. So what will be the final list that we'll have?
Option E.
Okay, option A. A. Right. So many say option A, right? So option A is the right one. So what we are doing here, so what happens when we iterate over a string? So because string is also a sequence data type, right? So the individual elements in the string are nothing but the characters that make up the string, right? Right, so each of these characters M A H E S H, so each of those are the individual elements in this sequence or the collection, right? So when we use a for loop to iterate over a string, so in each iteration, so we'll be having one particular character, right? So in the first iteration, I will take the value capital M. In the second iteration, I will take the value small a, and so on, right? So that's how the looping over string variable works. And what we are doing in each iteration, so we are each of the characters is also a string, right? Because in Python there is no difference between a single character and a set of characters, right? So a single character is also a string variable, and string variables have the built-in capitalize method. So what will capitalize do? Capitalize will give you it will change the case from lowercase to uppercase. But if it is already uppercase, then there is no change, right? So what it will do in each iteration, the characters that we have will be converted into uppercase, and those uppercase characters are added to this empty list one by one, right? So the append function will add it to the end of the list. So in the first iteration, what will we have? We'll have an empty list. So this empty list will become a list with one character, so which will be m, right? So in the second iteration, what we'll have, so we'll in the second iteration, l will no longer be empty, right? So because we already appended this character m, so this will become m, and then the capitalized version of the second character, that is a, and so on, right? So we are doing this for each character. So at the end of this loop, so all these characters would have been capitalized and then added individually to the list l. So the output that we'll have is MAHESH, all capitalized, right? So therefore the right option is option A. So if we run this, so we'll see that is the right answer. Okay, so for the next two questions, we'll be dealing with a data frame. Let's call it df underscore cars, right? So which when printed is as shown below, right? So we have an index of numbers, and then we have a car name, a type, brand, and price. So based on this information, we have to answer the next two questions, 19 and 20. So of the following set of statements, which of them can be used to extract the column type, so which is here, as a separate data frame, right? So you want the output to be a data frame. So we have four sets of statements, or three set of statements. A df underscore cars, which has passed a list with the column name, then df underscore cars using iloc, and then df underscore cars using loc. So which will give us the type column extracted into a data frame type.
A and C.
Okay, A and C. Any other answers? Okay, so let's just recreate the data frame. Okay, I'm just creating the data frame. So here we want the type column as a data frame output, right? So what happens is, so in the first one, so we are passing in a list of column names, right, to the indexing operator. So if you look at the output, so we are getting a single column as the output because we have given only a single column name. But if you look at the type of this output, it will be a pandas data frame, right? So typically when we extract a single column, so we won't be passing in a list of column names. So we just do this, right? So when you want a single column, you can access it, just by giving a string value, so which will be the name of the column. And in that case, you'll get the same output if you look at just the values. But if you look at the type of it, it will be a series data type, right? So when you access a single column like this, so what you typically get is a series data type. But if you want a data frame, then you have to actually pass in a list of column names, right? So if you pass in a list of column names, then instead of a series, you will get a data frame as the output, even though you ask for a single column. But if you want to access multiple columns, then this is the way. So you cannot just pass the two string names without passing it as a list. So you will by default you'll be doing something like this, right? So when you're accessing multiple columns, but when you're doing single column, you can still pass in a list of column name, or you can just pass in a column name, and depending on what you are using, either a list or a string, you will get series or data frame output. But here, since we wanted the output to be of data frame type, so we are passing in the single column name itself as a list of string. So in the second one, we are using the ILOC attribute. So what ILOC stands for? It stands for integer location, right? So which means we will be passing in the positions for the rows and the columns that we want, right? So for ILOC, we'll be passing in the row index as the the first argument, and then the column indices, right? So again, the index will start from 0 onwards if you by default, right? So if you don't change it manually. But here we are getting an invalid syntax error because we are not, this is not the right way to use the ILOC function. So if you want it, the right way, you should not have that extra open braces. So you'll be separating the row index and the column index using a comma, and here we want all the rows to be returned, so we are using colon, so which means all the rows, the default will be, starting will be 0 and the ending will be the length of the number of rows. So here it will be 5, so 0 to 5, so all the rows, and then we want only the column at index 1. So what is at index 1? So index 0 is car name and index 1 is type, right? So here, if we do this, we'll be getting the series output, right? So again, we do not want that because we want it as a data frame. But in addition to that, there is also the syntax error in this particular statement, which is this additional, open bracket. So B is not the right answer. If you look at C, so we are using the LOC function, LOC attribute. So LOC, works in a similar way to ILOC, but instead of using the integer positions, we'll be using the index labels, right? So again, the index label is nothing but for the columns, it is the name of the columns, and for the rows, it will be the whatever is there in the index value. So here the index and the integer positions are the same for the rows, right? So they are numbers starting from 0. But for the columns in the LOC, we are going to use the names explicitly instead of the integer positions. So here again, we are passing in the type, as the column that we want as a list, and then we are getting the output as a data frame, right? So out of the, the three that we had, so A and C will give us the output as data frames. Question number 20 is the method dfcars.describe will give a description of which of the following columns: car name, brand, price in lakhs, and all of the above. Option B, all of the above. Some also say option C, some say option D. Okay, so the right answer is option C. So we'll get the description or the descriptive stats only for the price column. So why is that? So by default, the describe column, what it does, it will give you the descriptive stats for the numerical data types, right? So if you go back and look at what are the 4 columns that we have car name, type, brand, and price, right? So if you look at the values that are contained within these columns, so the first 3 columns, so they are containing string data, right? So only price contains integer data, right? So the only numerical column that we have is the price column, right? So everything else is of the object data type in the pandas data frame. So by default, what the describe function does is it will only give you the description for the numerical data, right? So that's why only the price column will be in the output of the describe function. Okay, so next we are going to work with the CSV file called flavors of cocoa. So we have to read this as a data frame df cocoa and then answer the next 4 questions. Okay, so let's read that. So if we look at this, so we are having several columns, 7 columns. There are different companies that are getting this cocoa from from different countries, and then there is a rating that is given and the origin of the cocoa beans, right? So from which place they are being obtained, and this ratings are given on obtained at some time, right? So the review date is there. Looking at this, it looks like the review date is the year in which we got this reviews, and also the percentage of cocoa in those beans is also given. So that's the data frame that we have. The question is, which of the following columns has null values? Okay, so we have our options as ID, company, review date, and rating. So we also have a ID column separately, so which is nothing but the index, but starting from 1. So to do, how do we find null values? So to find null values, we can simply use the info function associated with the data frame. So that will just give us a overall summary of how many non-null observations are there in each of the columns, right? And also the data type of the column. So if you look at this, we have in total 1795 observations or rows, right? That is indexed from 0 to 1794. And for each of those individual columns, we can see how many non-null values are there. So in ID, all those 1795 are non-null. Company, bean origin also has those 1795 non-null. So only the review date column has 4 null values, right? So because 1791 are non-null, which means 4 values are null in the review date column, right? So all the other columns are non-null. So for this, the right answer is review date, right? So ID, company, and rating do not have any null values, right? So to quickly get these number of null values, you can use the info function. So the next question is, which of the following countries have the maximum locations of cocoa manufacturing companies, right? So the options are UK, USA, Canada, and France. So for this, we need to look into the company location column, right? So if you look at the company location column, so we have for each row is basically representing one company that is procuring these cocoa beans from a particular location, right? So if you look at this, so different the companies are located in different locations, right? So if you look at the unique values in this, so they are from all these different countries, located in these different countries, right? So what we want is in which country the maximum number of cocoa manufacturing companies are present, right? So some of these countries have multiple companies that are producing this cocoa. So to do that, what we can do is we can make use of the value counts function. So, right, so what value counts does is, for each of the unique values that you have in this particular column, how many times that does that unique value repeat in your data frame, right? So if you look at USA, so that is repeating for 764 times, right? So we have 754 entries where USA is the value in the company location column. Then there is France and so on, right? So by default, value counts will give you this information in the descending order, right? So the most occurring value will be at the top and then it goes in descending order. So just all you have to look at it is the first value, right? So that is the most occurring value. So USA is the location where most of these companies are present, right? So 764 such companies or observations in our data frame are from USA. So that is the country which is having the maximum location. So therefore, the right option is USA. Right. So then 23, after checking the data summary, which of these features requires a data conversion considering the data value scale? Rating, review date, company, bean origin. Right. So if you look at the info column, what is the current type of data that is used for these columns? So rating is having float data type. Review date has also float data type, and company has object data type, and then bean origin also has object data type, right? And then if you look at the values that are there in these columns, so company is containing strings, right? So the name of the companies, so representing it as object data type is fine, right? So there is no issues there. Similarly, bean origin is also the name of the location from which the bean is coming, so that is also a string data type, so object data type is fine for that. Then we have rating. The rating is, so we have some floating point numbers, right? So 3.75, 2.75, and so on. So floating point numbers. So float 64 is also fine for rating. So the other column that we had was review date, right? So review date, by looking at the values in it, so we see that it is currently represented as floating point numbers, right? So but if you look at the values, it is looking like it's only containing the year, right? So the year is represented as a floating point number, but actually an integer is enough for it, right? So decimal numbers do not make sense for the review date here, right? So basically it's a year value. So we need to convert this review date into integer data type. That's more appropriate for this particular column, right? So the only data conversion that we need here in this data frame is for the review date column from float to integer. Okay, then the last question with respect to this data frame, what is the maximum rating for the chocolates? So 1, 5, 3.18, and 4, right? So this is basically from the rating column that we have to have, right? So for each observation, we have a given rating, right? So that is a floating point number. So we need to find out which one has the maximum or what is the maximum value for the ratings that we have. So how can we get the maximum value? So we can use the max function, right? So we can just access the rating column using the indexing, and then we can call the max function on it. So that will give you what is the maximum value in that particular column, right? So in the rating column, the maximum value is 5.0, right? So 5. So the right answer is option B. That is the maximum rate. Yeah, so if you are asked to use these functions, so I think you may have access to the interpreters, or it will be a small data set um, that you can just look at. Any other questions?
No, sir.
Okay. Moving ahead, what will be the output of the following code? So we are importing NumPy, creating a list containing true, 2, 3.0, np.nan, and then a string false. So the output is basically a list that we are creating by looping over the values in p, and then appending the type of those values in a list. So what would be the output?
Option A, sir.
Option A. Right. Yeah. So option A. So if we look at this, so what we get, so the output will be Boolean, integer, floating point, and then string, right? So true or false. So it belongs to the Boolean data type, right? So 2, so without any decimal part, so that will be an integer. But 3 have with a decimal point, so it will be, even though this is an integer, but when we use a dot, right, so it will be taken as the floating point number, so it will be float. So np.nan, so this is not a number, so then nan values in numpy, so they will be represented using the floating point numbers, right? So it will not be an integer or string or any other data type, so this is also represented using floating point numbers, so that will also be float. And then last, even though this is false and this is enclosed within double quotes, therefore it will be a string data type and not boolean. So this is the right option, option E. 26, what will be the output of this code? So we are creating an numpy array, 1D array containing 5 values, and then we are slicing it using this syntax colon colon 2.
Option B, sir.
Okay, B. Some say A. Yeah. So B is the right answer. So what we are doing here, we are doing the slicing of this array. So when we do array of colon colon 2, so what is the syntax? So it will be inside the slicing, so we have first we'll be
Stop,
mentioning the start
stop,
position, then we'll be mentioning the stop position, and then will be the step,
step
right?
position.
Yeah. So start from this point until this point, we want to take this many number of steps each time, right, to reach there. So when we don't mention a start value, so the default will be 0. When we don't mention stop, it will be the length of that sequence, right? And if we don't mention a step, it will default to 1. But what we are doing here, we are not mentioning start and stop, so that will that will be the default values, but step value we are mentioning it, right? So it will be 2. So starting from the first element, we want to go through the entire array, right? And we want to skip one element each time, right? So because we are taking a step size of 2, so we'll be so first we'll take the first element 1, so that is at index 0. Then we'll be adding the step to our index, right? So 0 plus 2, so then that will be the next element. So 0 plus 2 will be the index 1, so we'll be taking 3, and then again we'll be adding the step size 2, so which means we'll be skipping 4, and then we'll take 5, right? So the output will be 1, 3, and 5. Okay, so the next one is a big question. So here we'll be using some modeling. So we want to read this given information and then answer the next two questions. So then we have some data given to us, and the description of this is an automotive service chain is launching its new grand service station this weekend. So they offer to service a wide variety of cars. The current capacity of the station is to check 315 cars thoroughly per day. As an inaugural offer, they claim to freely check all the cars that arrive on their launch day and report whether they need servicing or not. Unexpectedly, they got 450 cars, and the servicemen will not work longer than the working hours, but the data analysts have to. Can you save the day for the new service station? So here you have been given a data set called servicetrain.csv that contains some attributes of the car that can be easily measured and a conclusion as to whether a service is needed or not. Now, for the cars they cannot check in detail, they measure those attributes and store them in servicetest.csv. So the problem statement is we want to use ML techniques to identify whether the cars require service or not. So we'll read the two data sets as train data and test data respectively and import all the packages that are required. So we'll be preparing the data in this way. First, we have to encode the categorical variable, that is service, which contains yes or no as 1 and 0 in both the data sets, and we have to split these into independent features and the dependent feature. And then we also want to do a logistic regression on it and then set the random state to 0, right? So what we are doing is we just want to do a logistic regression, right? So basically, there are more cars than what they were than the capacity of the service station, right? So they want to quickly, do a logistic. They need to have a model that can be used to quickly predict whether those cars, require servicing or not, right? So instead of doing a detailed check, right? So for that, they have collected some attributes. Let's look at what is there in the data. First, let's read the two data sets. So they are given as separate files, the training and the test data. So we do not have to split it ourselves. So if we just look at the training data, so we have different features that are measured, right? And then so these are numerical features, and then the target variable is basically a binary variable, right? S or no, right? So S means the car needs servicing, and no means the car does not need any servicing, right? So it's a binary data type, and it's also categorical, so therefore we are going for classification here. So the first thing that we want to do is because this service or the target variable is encoded as a string, right? So that's not suitable for passing into the model. So we'll be replacing this into the target labels, which will be integers. Okay. So to do that, we can make use of the replace function, right? So to the replace function for a particular series data type, so we can pass in a dictionary. So the dictionary will have keys as the old value, and the values will be the value that we want to be replaced with, right? So we want to replace the values, the value of string s with the value of integer 1 and the value of string no with the value of integer 0. And then we want to do this on both the training as well as the test data set. And then we are going to replace the old values with these new values. So once we do that, we look at the service train data frame again. So we have replaced those strings with integer values, right? So wherever there was no is now replaced with 0. Wherever there was yes, it is replaced with 1. Okay, now we don't have to do anything else, right? So because uh, I already checked that there were no null values or no missing values. So all the data was available. So we don't have to do further processing in this. Directly we can go for the modeling. And also we need to split this into the independent or the features and the dependent or the target variable, right? So because we want to pass these separately to the model, so we are going to split this data sets into the training features and the training target. Similarly for the testing also, the features and the target separately. So what we want to do is for the X or the independent features, we want all the columns other than the service column, right? So what I'm doing is I'm just saying drop the service column. All right. So when we use the drop function, what it does, it will drop the values that you are asking it to and then return the remaining ones, right? So when I say drop columns equal to service, so it will drop the service column and return the rest of the columns, right? So which is these four or the five columns. So that I'm storing it in the train underscore x variable. And then for the target, we only want the service column. I'm just accessing the service column and then saving it in train y. So it's the same thing I'm doing it for the test data as well. So if you look at the x, so we have only the features, and then if you look at y, so we have only the target, right? So we have prepared the data. So now for answering the question, the first question is, after we apply a logistic regression to this data, what are the correct observations from the resultant confusion matrix on the test data set, right? So from the confusion matrix, so we can look at what is the true positive, true negative, false negative, and some combinations are given here. We want to see which of these is correct. So in the description, we were also told, to set the random state to be 0 for the logistic regression so that we get the reproducible results. So we'll follow that. So I have already done the necessary imports rights at the start itself. So I'm just calling the logistic regression class and just creating an instance of it, calling it logreg. And then we are going to fit it on the training data, right? So the train X and the train Y are passed to it. So we have fit the model. And now let's look at the confusion matrix. So for the confusion matrix, I have imported the confusion matrix display. So this is from sklearn dot, the metrics package. And then it has a from estimator method. So to which we'll be passing in the fitted estimator. And then we also want to look at this confusion matrix for the testing data, that is test X and test Y. And so if we don't pass in the labels, so it will use the integer labels that we had 0 and 1. So if you look at this output, so this is the confusion matrix that you have, right? So the true label means that is present in the data, right? So when the data, the service variable in the data is 1, and when the service variable in the data is 0, and the rows and the columns are nothing but the predicted labels, right? So this is the model's output, whether the model set 0 or 1, right? So instead of 1 and 0, so we can also replace it with by the actual numbers, right? So we want 0 to be no and then 1 to be yes, right? So whether service is needed or not, so it will be replaced with it. Now what can we get from the confusion matrix? So we can get the four combinations, right? So the true positive, true negative, false positive, and false negative. So what is true positive? True positive is nothing but when the predicted true label matches the actual true label, right? So we have only two classes here, no and yes, right? So no is like false, and true is like true, right? So the positive class and the negative class. So when the actual label is yes and the predicted label is also yes, so that combination is the true positive, right? So we have 29 true positives. And then when the predicted value is no, and predicted value is no and the actual value is also no, so that is called as true negative, right? So because the model is predicting no, and those are also for the actual no values, so this is true negative. So we have 94 true negatives and 29 true positives. And then so when the actual value label is no, but the predicted label is yes, right? So which means that it's a false positive, right? So because the model is saying yes, but it's not actually yes, right? So because therefore it's called as a false positive, and the other column is called as the false negative, right? Because the model is saying no, that is a negative result, but in reality it is true or yes, right? So therefore it is a false negative from the model. So we have 7 such observations. So this is what we get from the confusion matrix. And let's look at the options. So first option says that true positive is 29 and true negative is 94, right? So if you look at the confusion matrix, that is correct because this cell is the true positive cell, right? So both are S, right? So we have 29 true positives and 94 true negatives, right? So therefore option A is correct. We have 24 true positives and 94 true negatives. So option B is basically the opposite of what is an option A, right? So it's interchanging negatives and positives. So B is not correct. And C says false positive is 5 and true negative is 94, right? So true negative, we already saw it is 94. So this part is fine. So false positive is 5. So if we look at it, so false positive is when the predicted label is S and the actual label is no, right? So that is 5, right? So false positive 5 is also correct. So option A and option C both are correct. Option B is incorrect and D is also not applicable because A and C are correct. Is it clear? Any questions here? How to read the confusion matrix? Okay. Okay, so moving ahead. So there is another question with respect to the same model. So the built logistic regression model is evaluated for its prediction accuracy on the test data. So what is the accuracy range in percentage of the predictions made on the test data? So we have 4 ranges given. So we want to basically evaluate this model using the accuracy metric, right? So accuracy is nothing but what percentage of observations, for what percentage of observations the predicted label matches the true label, right? So how do we get that? So we can use the accuracy score function. Again, this is imported from sklearn.metrics package. Okay. So we have to pass in the true labels and then we have to also pass the predicted labels, right? So we can get the predicted labels using the predict function. So you take the fitted model and then call the predict function, pass in the the test features. They will get the predictions for the test data set. So we are passing the true labels and the predicted labels to accuracy score function, and then this will give you the accuracy. This accuracy will be between 0 and 1, right? So if you want it as a percentage, you just multiply the output of accuracy score by 100. So then you have the accuracy in percentage, right? So therefore the accuracy of this model on the test data is 91.11%, and that is falling in this range, 90 to 95, right? So therefore the right option here is option B. Okay, so then the last question for today is a regression problem, right? The Global Happiness Index report contains the happiness score data with multiple features, and these features are economy, family, health, and freedom that could affect the target variable value. So prepare the data by following the steps given below and answer the following question. First, we have to split the set of independent and dependent variables on the given data, and then create a training and testing set by splitting the original data in the ratio of 3 is to 1, and then set the value for this random state variable in the train test split function to 1, right? So that we get the same split to what they have used. And then we are going to build a multiple linear regression model on this global happiness index data set, so which is given in this GHI report.csv. And the question is, what is the RMSE of the baseline model on the test data set? Okay, so we have to choose 2.5, 1.06 or 0.75. Okay, so first let's follow the steps that are given here to prepare the data. Let's read in the ghi underscore report.csv, and then if we look at the data frame, so we have those 4 columns, features, right? So economy, family, health, and freedom. So all these are numerical variables and they don't have any missing values if you look at the summary of this data frame. So there is no missing values to be imputed or taken care of, and all these are numerical variables, and the target variable is the happiness score, so which is also a continuous variable, right? So it's a floating point number, so continuous value, So therefore, we are going to apply regression model for predicting the happiness score. So how do we do this? First, we want to split our data set into the features and the target, right? So we are going to use the same, syntax that we used earlier. So we'll use the drop function to remove the target variable, right? So that we get the features in the X variable, and then we'll just access the target variable and then save it in the Y variable, right? So we have split the data set into two parts, the features and the target. Next, we want to divide this data set into two parts, right? Training and testing. So for training and testing, so we can use the train test split function. So this is from sklearn dot model selection package, right? So you can use this. So you pass in your features and your target. You specify what should be the size of your testing data, right? So the training data will be the remaining portion. And then we can also use random state because this train test split randomly splits the observations. So to have repeatability, you can set the random state to some value so that you get the same split every time you run this function. Right, and the question also tells us to set the random state to 1. And how did we choose the test size as 0.25? Because we were told to split it in the ratio of 3 is to 1, right? So which means in total, if you have 4 parts, 3 parts of the data should go to training and 1 part should go to testing, right? So 1 out of 4 parts for testing, which means 0.25, right? 25% of the data should go for testing. So that's what we are specifying here. The test size will be 25%, that is 0.25. Right, so once we run that, so we get the training and the testing data. So if you look at the size of it, train its shape. Right, so we had 158 observations. So 1/4 of it is 40, that is in the testing data, and 75% of it is in the training data, 180. Okay, so we are going to fit a linear regression model because this is a continuous variable is the target, right? So regression is this suitable method for this. So we are going to put it on the training data, and then we can make the prediction on the test data, right? Similar with the same fit predict, API of sklearn, right? So it doesn't matter which estimator we are using, the syntax is going to be the same. And then after predicting it, so we can calculate the RMSE, the root mean squared error. So the root mean squared error is again imported from sklearn.metrics package. We again pass the observed or the actual labels or the target value, and then the predicted values, right? So and the RMSE on this testing data set for the linear regression model is 0.458. Okay, but what was the question? The question was not this. The question was, what is the RMSE of the baseline model on the test data set, right? So the linear regression model that we have built, the multiple linear regression, is not the baseline, right? So that is our final model. So what is the baseline model? A baseline model is a reference model, right? So if we didn't have these features, right, how would we make these predictions? If we only had the happiness scores, right, and we did not have for the different observations, but we did not have these features, then how would we have predicted? So that would be our baseline model, right? And we want to the baseline model will be like a comparison for how well the model that we are building is performing relative to that, right? So and for regression problems, the typical baseline that we use is nothing but the mean of the target variable, right? So what is our target variable? The happiness score. So our predictions in the absence of all the features would be, our best guess for any observation would be the mean of these happiness score, right? So if I didn't know what is the economy value, family value, health value, freedom value, and if I only had these head scores, then the prediction that I would give is the average for each of all these values, so, right? So that is one way of considering the baseline for the linear regression or just regression in general, right? That is typically used. So we'll use that as the baseline. So in this case, the predictions will not change for all the observations, right? So the target value from the training data set is taken and its mean is computed, right? So if you take the mean score, happiness score, it is 5.386, right, approximately. And this is the prediction for all the observations in your data. So regardless of what is your, what is there in your test data, so you will use this as your prediction. right? So because it doesn't depend on the features. So if we compute the RMSE using this baseline prediction, so we'll pass in the true test y values, and then for the prediction we are just going to repeat our the mean prediction for all the observations, right? So np dot repeat will just repeat whatever value you are giving the number of times that you specify, right? So this will just be the mean value repeated 40 times, right? So because the shape of test y is 40, so you'll just have the same prediction for all the observations. And if you compute the RMSE of this, then the RMSE for the baseline model, so which is a mean model, is 1.06, right? So compared to this base model, if we build a linear regression with the predictors that we have, so we are able to improve the RMSE score from 1.06 to 0.458, right? So we are able to improve our model by considering the features, right? But the reference point is the baseline model. But you can use any other as value as your baseline as well. So instead of mean, you could use median, or some other way that you can come up with, that you want to benchmark against. In some cases, we'll use the linear regression itself as a baseline, right? So when we go for complicated models like say random forest or neural networks, so in that case, even linear regression is taken as your baseline, right? So it depends on the models that you are building, what you want to consider as your reference, in order for you to be able to evaluate how well the models that you are building are performing with respect to that baseline, to compute how much improvement you are able to bring in, right? So in this case, because we want to benchmark a linear regression, a simpler model is the mean model. Right, and the RMSE of that model is 1.06. So therefore, the right option is option C, 1.06. Any questions?
No, sir.
Okay. So with that, I think we have covered all the questions from the 4 weeks assignments. Okay, so if you have any questions in any of these, or if you have any other questions apart from these assignment questions, you can ask that. It's because since this is the last session that we will have, so any doubts that you have, you can ask now. No, I'm not in a position to answer regarding the submission of the assignment. So you can contact NPTEL; they'll be able to uh, answer that query. So what sort of questions? So again, I'm not sure. You have to write to NPTEL, but I would say it would. You just have to. It will be similar to what you have faced in the assignment. There'll be some theoretical questions, some practical or programming related questions. So it will be similar to the assignment that you are solving. So if you are familiar with, if you have solved the assignment, you should be fine. Well, these recordings will be available on YouTube, and the channel link I'll share it. So you can find these recordings in this YouTube channel.
Sir, how will be the question asked, sir?
Yeah, for all exam related questions, you please write to NPTEL regarding the fall patterns evaluation. So please write to NPTEL, so they'll be able to answer that.
Okay.
So any other questions with respect to the contents that we have discussed?
It will be available in YouTube, right, sir?
Yes, I've shared
What?
the link. Yeah, you can look at that. If low RMSE indicates good, yes, lower RMSE is better, right? So RMSE is nothing but how do you calculate RMSE? So RMSE is root mean squared error, right? So RMSE means root mean squared error, right? So what is error? So error is nothing but the difference between the actual value and the predicted value, right? So you have the true value and the predicted value. So you take the difference, so y minus y pred, so that is your error. And then squared errors. What is squared error? So you have to square the error value, right? So that is error squared, right? And then this you have to repeat it for all the observations in your data, right? So if you have 100 observations, so you'll be computing the squared error for all the 100 observations, and then you take the average of those uh, 100 squared errors, so that will give you the mean of the squared error, right? And the root mean squared error is nothing but the square root of these square root of the mean value. So why is smaller value better? Because so when will this value be high? So when the difference between your prediction and the actual value is large, right? So if the prediction is too far off from your y, then the square will also be large, right? So square will just make it much larger. And when you take the mean, so this is nothing but the average of all those the deviations from the actual value, right? So the square root will again bring it down to the same unit as your target variable. So when you have a higher squared root mean squared error, it means that your predictions are too far away from your actual value, right? So therefore, larger RMSE means larger errors in your data, and therefore a smaller value means that it is better, right? So the best value that you can have is 0, right? So when when y pred is exactly equal to y, then the error will be 0, the squared error will be 0, the average will also be 0, and the square root of 0 will be 0, right? So the best RMSE that you can get is 0, and any value larger than that is bad. So when you compare two RMSEs, the lower one is better. No, if you take mean or median, so depending on how close or far away the mean or median is in the baseline prediction, so the result may not be same. But because in the the lectures, the mean model was introduced as the baseline, so we are using that. But you can use anything else. But because we want to be consistent with what was given in the lecture, so we use the mean model here. And if the distribution of your target variable is asymmetric, right? So your mean and median in most cases will not be the same. For symmetric distributions, the mean and median will be the same. Any other questions? Yeah.
No, sir.
Okay. Okay, when to use which model? KNN, K-means clustering, random forest, and all. Right. So it depends on your problem, right? So last you have, so clustering is different from the other ones that we are seeing, right? So there are, at the top level we have two broad categories of problem. So we have uh, so we have supervised problems, and then unsupervised. So what does supervised mean? So supervised means where what is the actual the target value, right? So you have observed what is the when the output is observed, so in that case you can go for the supervised methods. When the output is not observed, when you have only the features to describe your observations, but what is the output value if you do not know, so in that case you can go for the unsupervised methods, right? So target value is available, and in this case it will be unavailable, right? So when you have within supervised learning, so depending on the the type of your target value, right? So you will go for categorical classification or regression. So when you have categorical target, so you will be going for classification problem, right? So methods that can do classification, and for continuous variables, so you'll be going for the regression problems, right? So regression methods, right? And all the different estimators that are available out there. right? Most of them support both classification as well as regression, like random forest chain and uh, uh, gradient boosting algorithm. So all these have classification algorithms as well as regression algorithms within those methods, right? So that is the first level that you see. Look at the target value. Depending on its type, you look at whether you want classification or regression, right? So, and within unsupervised you have typically the clustering methods. And for clustering, again, there are different number of algorithms that are available, right? So each of the algorithms have their own requirements, all right? So some, clustering algorithms require you to specify how many clusters are there beforehand, right? So like, for example, if you use k-means, right? So this requires you to specify beforehand how many clusters you need, right? So some other algorithms like agglomerative clustering or others, so they does not require you to specify or they will infer the number of clusters in your data set, right? So it depends again on your problem that you have, whether you already know these many clusters are there or you want to find out from the data. So depending on that, and also other factors or features of that method, so you decide which method you want. Again, in this classification and regression supervised problems, different estimators are there, as you have mentioned, Kane and random forest and so on, decision trees. So each method has their own pros and cons, right? So for example, there are simpler methods like decision trees that are more, interpretable. So you can look at how the predictions are made with that. When you go for ensemble methods like random forest or gradient boosting, it's much difficult to understand how the model is, coming up with the predictions that it is coming. So explaining those models become more difficult, and also depending on the amount of data that you have, right? So for example, linear regression doesn't require that much data in order to work with, whereas if you want to go with more complex models, typically the data that you require to get good predictions would be much larger when you want to generalize well. All right, so there are a number of factors that decide, which model would be better for a given problem, right? So also some of these models will take more time to train, right? So the computational budget is also one aspect that you need to keep in mind. So depending on looking at all these factors, you would be, choosing the method that you want to use. Typically, what you would do is when you have the resources, and the data that is available, you can try all these different methods for your data and then choose the one that is performing better, right? So you can have the training and testing split and then apply all these different algorithms that you have, right? And then look at which is performing the best and then use that, right? So that is also one way that you could go about it. Okay, some doubts about keywords. Yeah, what is the doubt that you have? So yield keyword. Okay, so yield is basically used for for generators generally, right? So for example, if you are creating a function, okay, let's say 0, right? So when you use yield, instead of return, so what you will get is basically a generator, right? So generator means you can call the next function and then it will generate a particular value, right, out of it. So for example, if I had defined this a outside, right? So the yield will basically give you a generator instead of a particular value, right? So generators are basically something that you can iterate over, right? And each time you iterate over, it will give you a value instead of the whole value is generated at the time. Only when you are calling it, it will create the value and not beforehand. Target value is the dependent value which we use it for test data, not just for test data. So the target value is present both in your training as well as testing. So target value is the one that you are trying to predict, right? So the variable that you're trying to model in your in your models, that is the target value. For example, in our the last problem, the happiness score is your target variable, right? So you're trying to predict this particular variable's value as a function of the different features that you have, right? So it will be present both in your training as well as in your testing data, right? So when you're training it, you are telling the model, look at these features, right? And come up with a function that will give me, this particular value, right? So that the target value. And then once the model has been fit, so what you can do is give a set of features and then get the model's predictions so for those particular observations, and then you can compare that actual true value for the target with the predicted value. So the target variable or the dependent variable is the one that you're trying to model or trying to predict. Okay, any other questions?
No, sir.
No. Okay, so if there are no further questions, we can conclude our session. So all the best for your exams. You do well. I hope you would have found these sessions helpful. So thank you again for attending. Yeah, all the best.
Sir, what about non-local keywords, sir?
Yeah, so non-local, so you'll be using the non-local keyword in the context of nested function. So in Python, you can define one function within another function, right? So in those cases, sometimes you can use the same variable within those nested function, right? So in that case, the non-local keyword is used when you're creating, the particular variable within your inner function. So you have one outer function, and then you have an inner function. And if you use some variable that is defined in the outer function, right? So in that case, you can use the non-local uh, keyword to say which variable, should the inner function, modify, right? So if you do not say non-local, right, then what happens is, Python will modify the variable that you have inside your inner function, so that will not be reflected in the outer one. So let me show you an example. So let's create a function. Let's call it outer. Let's say this has a variable a equals 5, and then we can create another function within this, right? So if we use the same variable name here, inner 6, with an inner a is equal to 6, and when we are returning a, so what will be the output of the call to the outer function? So the call to the outer function will give me 5, right? So even though the 6 is there inside, so the call to the outer function right? And let me just call this. Right. So what I'm so what when we call outer function, what happens? So we call this function. So we create a variable a 5. So we are defining another function within that which sets a equal to 6, and then we are executing it. So when we execute it, a will be set to 6. But when we return a, what we are getting is the value 5, right? So this part is not reflected when we are returning it, because this a is belonging to this inner function, right? So even though we are using the same name, this a is created separately for this function, and it is not referring to what is there in the outer scope, right? So but here if we set non-local a, so then we get the value as 6. So what we are saying here in the inner function is non-local a means do not create a variable a separately for this inner function, right? So use the variable if it is available outside this function, then refer to that one within this function, right? So when we set a equal to 6, so we are not creating a separate variable a, we are referring to the variable outside, right? So that is non-local. So local means local to this particular function, but this a is non-local, which means it is referring to something outside this function's scope, right? So that is in the outer scope, a is equal to 5. So when we call this function, so the modified variable a is not something that is local to inner, but it is the one that is here. So therefore, when we return a, so we are getting 6 here, right? So that's the difference between creating a local one and a non-local variable. So when you don't specify non-local, so it's by default local to that particular function.
Okay, sir. Sir, last question, sir.
Yeah, go on.
Will they ask question about turtle, sir?
About
Turtle.
turtle, no. So turtle is for like creating GUI applications, right?
Yes.
Yeah, so that is not part of the syllabus.
Okay, sir. Will there any session, sir?
No, this is the last session, so you won't have any more sessions.
Okay, sir. Thank you, sir.
Okay, thank you everyone. Let's close the session here.